Okay, in this video, we're going to talk about equivalent fractions. Equivalent fractions. So some of you have these little fraction pieces, and we were working on this a little bit last time, how we use these. So what did you notice in terms of like, can I make thirds equivalent to fourths? Can I? It's a hard question. Well, look at them and see, are any of them, could any of them line up to being equal? No. Could I make halves into fourths? And why is that, do you think? Why can I make halves into fourths but not thirds into fourths? Because 2 times 2 is 4, right? 4 is a multiple of 2. So 1/2 is equal to how many fourths? 2/4. And this is the cool thing, this is why I want you using your fraction strips, is so that you can actually see that they're exactly equal to each other. 1/2 is equal to 2/4. Now there's this other thing that you brought up before. It's called, now you can notice that I multiply 2 over 2. I multiply by 1 in order to make an equivalent fraction, right? So 1/2 is equal to 2/4. There's this other thing called the cross products principle. Okay, cross products. What does the word product mean? Product means, yeah, multiply. Okay, two equivalent fractions actually have a special name, and we're going to look at these more later, but I just want to give you the name so that you'll have it for later. Two equivalent fractions is called a proportion. Proportion. Have you heard that word before, proportion? Proportion, it just means two equivalent fractions. Okay? Now the cross products are equal. So if I go 1 times 4, 1 times 4, is that equal to 2 times 2? That's the cross products. Cross product means I multiply across. 1 times 4 is 4. 2 times 2 is also 4. Okay, let's use our fraction pieces to find as many equivalent fractions as we can. So can anyone use their fraction pieces to find any fractions that would be equivalent to 1/5? If I said find fraction pieces that are equivalent to 1/5, what fraction strip would you grab automatically, do you think? You would grab tenths. Good. Why tenths? Why tenths and fifths? Oh, yes. Okay. Now, let's say you have 3/5. Okay, that's 3/5. How many tenths are equal to 3/5? Does everybody see that relationship that he's showing us? I'm going to move this up a little bit higher. Okay. 3/5 is equal to 6/10. Now, we can also prove that by doing the cross products. If these fractions are equal, their cross products will be equal. 3 times 10 is equal to 6 times 5. Is that true? I'm moving it out of the way of that little record button. Is that true? 30 equals 30. 30 equals 30. That's their cross products, okay? Now, find me some fractions that are absolutely not equivalent. Give me any two fractions, and let's just double check that they're not equivalent. What are some other fraction pieces that we can come up with that are not equivalent? Yes, I love it. So 1/12, oh, look at that relationship there. There's 1/5, there's 1/12. What would you say, which one is bigger? Yeah, because if I had a candy bar and I cut it into 5 pieces, those pieces are going to be bigger than if I cut it into 12 pieces. right? All that is a division problem. So if I eat 1/5 of the candy bar, that's a lot more than 1/12. That's why you have to look at the serving sizes on things. You know how you look at, you get a bag of chips and you're like, oh, I ate the whole bag, and they said, well, how many servings were in the bag? How many servings were in the bag, do you think? 3 servings. So you ate 3/3, or you should have had 1 serving would be 1/3, right? Okay, so we know that these two fractions are not equivalent. 1/5, we're going to say right now, is equal to 1/12, even though they're not equal. I'm going to set them equal. Let's try the cross products. Is 1 times 12 equal to 1 times 5? Is that true? 12 equals 5. So what we've shown here is that the cross products are only equal if the fractions are equal. Can anyone else tell me, using your fraction pieces, any other fractions that are equivalent to each other? Just grab one strip and another strip. Your favorite 2 strips. Tell me what they are. We're all shy. Okay, I'll start you out. How about grab 1/3? I'm going to slide this over so I have more space. Grab 1/3. Now somebody tell me, what is one fraction that you can grab? What one other fraction piece can you definitely line up? Okay, 1/6 will line up. And I had it in my hand. 1/6 will line up. 1/12 will also work. Why is it that 6s and 12s work so well with thirds? Yes, exactly. They're multiples. 6 is a multiple of 3, and 12 is a multiple of 3. Because when you count by 3, you're multiplying by 3. 3, 6, 9, 12, 15, 18, 21. Those are all multiples of 3, right? So give me some fractions that are equivalent. Just pick one. Let's pick either, do you want 1/3 or 2/3? How many thirds do you want? 2/3. Okay. 2/3, give me a fraction that it's equal to. How many 6s? 4 6s. 4 6s. Now we could cross multiply. That's 12 and 12, so they're equal. 2/3 is equal to how many 12s? 1, 2, 3. 1, 2, 3, 4. 1, 2, 3, 4. How many 12s? 8. What do we have to multiply 3 by in order to give us 12? 3 times 4, right? 3 times 4. That means 4, you're going to multiply, you are going to always multiply the same thing in the numerator and the denominator to make that equivalent fraction. What did I multiply 3 by to give me 6? 3 times 2, good. And then that means I have to do the same thing in the numerator. So notice that you can only make equivalent fractions if the denominator goes into these other denominators, or basically those denominators are always going to be multiples of each other, multiples of 3. Is that making sense? A little bit? Okay, and reducing goes the opposite way. We never want to end up with the fraction 8/12. 8/12 we always want to reduce. So we always want to ask ourselves, well, what number goes in evenly? And that's how we make it into simplest form. If we can line up 8/12 with 2/3, okay, we can also say, well, 4 goes into both of these evenly, so I divide both by 4. 4 goes into 8 2 times. 4 goes into 12 how many times? 3 times. That's how we reduce. We want to find a number that can divide evenly into the numerator and the denominator. We call this number the greatest common factor, the GCF. Okay? That's what that number is. So now you should be able to